Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can do different operations on functions. So what we're talking about here is how we can add functions, subtract functions, multiply functions, and divide them. So sometimes we'll see something like f plus g of x, but really what that's saying is we're taking two functions that we're adding together, and we're going to add them separately. So that's the same as f of g plus f of x. Or f minus g of x is a way of saying that I want to subtract f of x minus f of g. Notice how the f comes first and the g comes second here. Because subtraction is not commutative, or we can't switch the order, we need to make sure that we're being consistent there. Then we have multiplying, where we multiply the two functions, and last we have dividing. Now, we have been talking about radical functions recently, but these operations on functions actually apply to any type of function. We can do it with polynomials, we can do it with radicals, we can do it with exponentials, whatever it is. We can even combine cross types. So we can combine a polynomial with a radical function, as long as we're being consistent in what we're doing. So let's take a look at a couple of examples of each of these. So first, let's take a look at adding two functions. So remember, if we're adding two functions, we add the first one plus the second one. So let's take a look at this example here. It says let f of x equal 3 root x and g of x equal negative 10 root x. And we want to find what f plus g of x is. So what that means is we're going to do f of x plus g of x, and we want to figure out what that equals. So we've got 3 root x plus negative 10 root x. Well, 3 plus negative 10 is actually going to give us a negative 7 square root of x based on those properties of adding radicals. So now that we have this, we want to state our domain. Now, if we want to find the domain, a really easy way to do this is to actually graph it. But in this case, knowing that this is a function, our domain here is actually going to be any number greater than 0. And we know that because we cannot put a negative number into a radical sign if we want a real solution out. So our domain is all of the positive numbers, and we want to evaluate it at x equals 4. So what that means is we are going to do f plus g of 4, which is the same thing as doing 4 in both of them, or negative 7 times the square root of 4. Well, the square root of 4 is 2, so we get negative 7 times 2, which equals negative 14. Okay, so we kind of see how that works. Let's look at one more example of adding functions. In this case, we've got two polynomials. We're going to add the polynomial f of x, which is 4 to the 4th, and g of x, 24 to the 4th plus x. And then we're going to find its domain and evaluate it. So let's take a look here. We've got 4x to the 4th plus 24x to the 4th plus x. Now notice we have our polynomials here that are being added together. We need to make sure that we are adding that whole polynomial, or subtracting when we get to subtracting. So these combine here, and we end up getting 28, because 4x to the 4th plus 24x to the 4th is 28x to the 4th plus x. Okay, so here is our new function. So f plus g of x equals 28x to the 4th plus x. Now what we want to do is find our domain. Now, sometimes like that with that radical function, it's easy for us to interpret what our domain is. In times that we're unable to interpret it directly, one great resource that we have is actually Desmos.com, which I'm going to pull up right here. So we are going to go to Desmos.com and take a second to graph this. So we are going to enter into our graphing calculator, and let's take a look as to what this is going to look like here. So we've got 28x to the 4th plus x. And that is going to look like this. So notice how our domain is actually going to be all the real numbers, but our range is what changes here. So let's go ahead and open this all the way back out. And our domain here is all the real numbers. Fantastic. Then the very last step that we have is we want to evaluate it at x equals 4, which means we'll put a 4 in here. So f plus g at 4 is equal to 28 times 4 to the 4th plus 4. And so let's take a look at what this is going to end up being. So 4 to the 4th power is 256, and that times 28 is going to be 7,168 plus 4 more gives us 7,172. Awesome. Okay, so that's how we can add functions. Now let's take a look at subtracting them. So subtracting them is very similar, but what we're going to do when we subtract is we need to make sure that we're staying consistent. So in this case, we want to let f of x be 3x to the third minus 2x squared plus 5x, and g of x is x to the third minus 3x squared plus 4x minus 2. So if we want to find f minus g of x, we need to subtract these two polynomials. So that's 3x to the third minus 2x squared plus 5, that polynomial minus x to the third minus 3x squared plus 4x minus 2. Now, because we're subtracting this whole thing, we need to change the signs and turn it into an addition problem. So this is 3x to the third minus 2x squared plus 5 minus x to the third plus 3x squared minus 4x plus 2. Notice how all the signs changed on this one. Now we can combine those ones that are like. So these two here become a 2x to the third. These two pieces here will end up giving us an x squared. We have this minus 4x, and then 5 plus 2 is 7. Okay, so this right here is f minus g of x, and that's going to be 2x to the third plus x squared minus 4x plus 7. Now to find our domain, we are going to actually have a domain of all the real numbers, because this is a polynomial function there, and so we're not limited. And then we want to figure out what happens when we plug in a -2. So we want f minus g of -2, and we're going to plug that right in here. So 2 times -2 to the third plus -2 squared minus 4 times -2 plus 7. And we can type that right into our calculator. So again, we've got 2 times -2 to the power of 3 plus -2 squared. And it's important to make sure that you type it in exactly as it's written with those parentheses. -4 minus 4 times -2 plus 7 equals, you guessed it, 3. And so that's what happens when we evaluate it there at -2. So again, subtracting, especially when we have polynomials, we need to make sure that we're being consistent and subtracting the whole thing, not just the first term. So we want to apply that subtraction to all the pieces. So let's take a look here at this next example. Now notice how our functions are the same as they were in this problem, but in this case, we are actually subtracting them instead of adding them. So we are going to do 4x to the fourth minus 24x to the fourth plus x. So how is this function going to change? Well, our f of minus g of x in this case is going to be 4x to the fourth minus 24x to the fourth minus x, which is the same as -20x to the fourth minus x. Awesome. So our domain in this case is still going to be all the real numbers. Remember, whenever we have a polynomial function, their domain is typically all of the real numbers. And then we want to evaluate at when x equals 4, so f minus g of 4, that looks like a -4 there, but I promise it's just a 4, equals -20 times 4 to the fourth minus 4. Now we can type this one right into our calculator there. So we've got -20 times 4 to the fourth minus 4 equals -5,124. Fantastic. Okay, next we're going to take a look at how we can multiply functions. So again, when we're multiplying functions, all we're going to do is take the original function and multiply it times the other one. So in this case, we've got an x squared times a square root of x. Now these ones are two different functions. One's a polynomial and one's a radical function. But remember, I can rewrite this radical function here with an exponent. So this is really the same as x squared times x to the 1/2. Now because these two numbers have the same base, we can actually add their exponents. So what this means is that f of g to the f times g of x equals x to the 2.5. Or oftentimes we'll say that as x to the 5/2. We typically write those exponents in in improper fractions rather than in proper fractions. Okay, now that we have this as our answer here, we want to state our domain. So again, sometimes it's great to be able to know what that domain is. And so an easy way to find it, just like we can at any other point in time, is to graph it. And when we graph this polynomial, what we end up seeing is we end up seeing something that looks kind of like this. Now, because it's only on that one side, our domain in this case is actually going to be just like with that radical function, 0 to infinity, where it starts right there at that 0. And we don't have any points that exist below it. Then the last thing we want to do is evaluate at x equals 9. So we're going to put 9 into our equation there with our 5 halves. I promise we can type that in. And as I put 9 into my function, 9 to the power of 5 halves equals 243. Fantastic. Okay, so again, that is how we can multiply those polynomials. Let's take a look at one example here with that generic one that we've been adding and subtracting. Now we're going to multiply it. So f of g, or f times g of x, equals 4x to the 4th times 24x to the 4th plus x. So what is this one going to do? Well, we're actually going to multiply these polynomials together. And we're going to do 4 times 24, which is 96. We are going to add our exponents, so x to the 8th plus 4x to the 5th. Okay, so this is that f of g of x. Our domain in this case of that f of g of x is going to be as a polynomial function. We are going to end up getting that our domain is all the real numbers again. And then our last piece is that evaluating. And so we are going to have to evaluate this piece here. And when we evaluate it, that means that we're going to put in 4 everywhere that there is an x. So we've got 96, 4 to the power of 8, plus 4 times 4 to the power of 5. Now I'm telling you, this is going to be one big number. 96 times 4 to the power of 8, plus 4 times 4 to the power of 5. Is going to give us a whopping 6295552, also known as 6,295,552. Wow, that is a big number. Okay, now we're going to look at 2 last examples. In both cases, we are dividing our functions. And so that's where we take f divided by g of x. And that's where we will look at the function f and divide it by the function of g. Let's take a look at this example here. So in this case, we've got 6x divided by x to the 3/4. Now, when we're dividing these, we can actually subtract the top from the bottom. So this is 1 and this is 3/4. So this is really 6 times x to the 1/4. And x to the 1/4 is really the same as saying 6 times the 4th root of x. And so that's another way that we can find that. And we also want to make sure that we simplify it as much as possible. And so again, in math, we typically would prefer to have a radical than an x to the 4th, but that x to the 1/4 power is not a wrong way to do it. We just want to make sure that we are being consistent there. So as we are finished with this, we are now looking at our domain. And in this case, our domain of our function is going to be all of the positive numbers, just like we see with any of those even radicals. And then lastly, we want to evaluate it at x equals 4. So 6 times 4 to the 4th root. This is going to be that f of g of 4. Now, when we type this into our calculator, because the 4th root of 4 is not an easy number to calculate, so 6 times we've got to get that 4th root in here. So the 4th root of 4 times 6 is going to end up getting us 8.49. Fantastic. So we are going to take a look at one last example here. Again, that's our 2 favorite functions, and we're going to divide them. Now, let's take a look at these ones here. We've got 4x to the 4th divided by 24x to the 4th plus x. Now, we will get to this in future chapters when we talk about rational functions. But one thing we can do is factor out our greatest common factor here to simplify it. So we get a 4x to the 4th over an x times 24x to the 3rd plus 1. And we can actually get rid of one of our x's on top and bottom. So we get 4x to the 3rd over 24x to the 3rd plus 1. Okay, so this is a simplified form as we divide it. Our domain in this case, as we look at our function there, is going to be 4x to the 4th divided by 24x to the fourth plus x. And as we graph this function, here's just a heads up for those of you that are not currently graphing it. What we end up seeing is a function that looks like this, which means that we end up with a vertical asymptote when x equals 0. And we know that that happens because of that x that we can factor out there. So it actually goes from -infinity to 0 and from 0 to infinity, but it does not include the number 0. So literally every number but 0 works in this function here. And our very last step is evaluating it when x equals 4. And so we're going to stick with this original function here to evaluate it. And I'm going to do f over g times 4 equals 4 times 4 to the fourth divided by 24 times 4 to the fourth plus 4. Now, as we evaluate this at x equals 4, what we're going to end up getting is 0.167 is roughly what we get. Now, it does give us kind of a longer answer there, but that's essentially where we end up getting is at 0.167. So that is how we can do different operations of functions. Again, if we're adding two functions, we just add them. If we're subtracting, we subtract them, multiplying, dividing. And so notice how those domains and ranges can be affected. A great way to look at those, and we can use them to evaluate these two different things. But that is operations on radicals. If you have any questions, feel free to reach out.